Hi guys, it's Mrs. Hoekstra, and I would like you to go to lesson 10.3, operations with radical expressions. There's a warm-up there, and I would like you guys to answer. Decide if the expression is simplified. Just put a yes or no. However, if it is no, I want you to simplify it so that I can tell if you do have the exact idea down. So I'm going to ask you guys to pause this video at this point, and then I'll put the answers back up. All right, so here are my answers. All of them are no except for the very last one. So the first one there should have become the square root of 4 times 6, which becomes 2 root 6. The next one, I reduced the fraction first, and I turned that into 1/2. So I have the square root of 1 over the square root of 2, but that's illegal. So the square root of 2 over the square root of 2 gives me the square root of 2 over 2. Next, I have the answer is no, and I just reduced. 4 goes into itself once and into 8 twice. Then we've got this next one. I have to multiply both the top and bottom by the square root of 2 to rationalize the denominator. So I get 4 square roots of 2 over 2, but I can reduce that fraction. So I end up with 2 square roots of 2. And then last, I can multiply. And on this one, I end up multiplying 3 and 4, so I have 12. And then I multiplied the square roots, and I got the square root of 108. But I know that the square root of 108 is the square root of 36 times 3. And so this becomes 6, of course, so I have 12 times 6 square roots of 3, so I end up with 72 square roots of 3. You may have done that problem differently and still got the same answer, though. And of course, this last one, the answer is yes. The denominator is rationalized. I cannot simplify the square root of 26. I can't reduce anything, so I'm all set. All right, go across the page if you would. So what are the steps to add or subtract radical expressions? First of all, they must have the same radical. It's like having to have the same variable, right? You can't add x's and y's to each other. You have to have the same radical. Simplify the radical to combine them. Look for common radicals if we can, and then add or subtract the coefficient, just like you would if it was a variable. And then keep the common radical, again, like you would if it was a variable. So almost think of the radical as kind of like a variable. Okay, it's like a variable. So let's take a look at what we got going on. So we have 2 root 6 plus 5 root 6. So first of all, they have the same radical, so we're good. All right, so now we're going to simplify or combine or do anything if we have to. We don't. So now we're just going to add the coefficients. So I'm just going to add 2 plus 5, right? Square root of 6. That's what I'm thinking. This is my little thought. This is my thought bubble. And then I've got 7 root 6 is my final answer. Like pretty straightforward. Same thing for subtracting, right? Same thing. 7 root 2 minus 8 root 2. I'm just going to, in my head, do 7 minus 8. Right? 7 minus 8, negative 1 root 2, or just negative root 2, right? Any of those are the correct answers. That first one's just my thought bubble of what I'm doing. So let's keep going. 5 root 3 minus square root 12. Do they have a common radical? The answer is obviously no. So now I need to try to get them to have a common radical. It's probably going to be easiest for us to do that with the 12. So let's think about what makes 12. 12 is the square root of 4 times 3. And that's helpful because I want to have that root 3 there. So I actually have 5 root 3 minus 2 root 3, right? And 5 minus 2, I end up with 3 root 3. What about 4 square root 7x plus 2 square root 28x? We'll take a look at this one. This first one here is the most simplified versus the 28x. So I'm probably going to break the 28x up, right? I'm going to take the square root of 28 and make it become the square root of 4 times 7x. I want those two to match. So I will have 4 square root 7x plus 2 times the square root of 4 times 7x. Right? But I know the square root of 4. That's 2. So I'm going to have my 4 square root 7x here, plus 2 times 2 square root 7x. And we know 2 times 2 is 4, so I have 4 root 7x plus 4 root 7x for a grand total of 8 root 7x. Now, I went through a lot of steps there. Some of you guys might be able to skip some of those. I get that, but I'm making sure everybody understands since I'm not here. What about 4 square root 7 plus 3 square root 2 plus the square root of 8? Well, first of all, I notice, 7 and 2 are both prime. So I'm probably not going to be able to ever get those two to combine. However, my square root of 8, I can simplify. And so the square root of 8 is the same as the square root of 4 times 2. And that's going to be helpful because now I've got that one. So my 4 root 7 is just going to hang out front, plus 3 square root 2 plus this becomes 2 square root 2, which means I can combine those two because they have the same radical. 4 root 7 I cannot combine because they don't have the same radical, plus 5 root 2, and there we go. All right, last one. Ooh, what's your gut say to do with these? Square root of 10 times the quantity of the square root of 6 plus 3. Well, most of the time when we have a number outside of the parenthesis, we usually distribute, and go ahead and feel free to do that. So I'm going to end up with the square root of 60 plus 3 square roots of 10. You're like, okay, now what? If I break this into 6 times 10, because that would make sense, but I can't take the square root of 6, so that's not going to help me at all. So I'm actually going to break the square root of 60 into what I do know works, 4 times 15, right? Because I know that's the perfect square, the largest perfect square that goes into 60. So I'm going to make this become 2 square roots of 15 plus 3 square roots of 10. I would love to combine those, but I cannot. There's nothing that I can factor or deal with to make that any more simplified. So that is actually the final answer. All right, top of the next page. And if I'm going too fast, feel free to pause. So we have got what, if this was, in the quadratics unit, we would FOIL this out. So that's what my gut instinct says to do on this next problem. Let's FOIL this, right? So the square root of 2 times the square root of 6 is going to be the square root of 12. The square root of 2 times 5 is 5 root 2. 3 times the square root of 6 is 3 root 6. And 3 times 5 is 15. Okay, is there anything I can do to simplify this? I can simplify the square root of 12. The square root of 12, we know, is the square root of 4 times 3. And we know that the square root of 4 is 2. So I'm going to make that become 2 square roots of 3. So 2 square root 3 plus 5 square root 2 plus 3 square root 6 plus 15. Can I simplify, combine, do anything? No, I cannot. I sure wish I could, but that actually is the final answer. Take a look at the second problem. It's really kind of interesting to see what happens. We have seen problems like this when we are working with our quadratics. And we got an interesting pattern. We got like a perfect square trinomial. Well, with the radical, it is different. So let's write this out as the square root of 11 minus 2 times the square root of 11 minus 2, and let's FOIL it out and see what happens. So the square root of 11 times the square root of 11 becomes 11, right? Square root of 11 times the square root of 11 is the square root of 121, which we know is 11. So we can just jump to that answer. All right, the square root of 11 times negative 2 is negative 2 square roots of 11. Then we'll do the inside. Negative 2 times the square root of 11 is just that, negative 2 times the square root of 11. And negative 2 times negative 2 is positive 4. Okay, so now I've got 4 and 11 I can combine, right? And then I can combine these because they have a common radical. Minus 4 root 11. So I end up with 15 minus 4 root 11. So as much as we thought it was going to be a perfect square trinomial, it actually does not. Okay, last one on this page. Let's see what we've got. We have the square root of 6 minus 2 root 3 times the quantity of 4x plus, or excuse me, 4x, 4 root 3 plus 3 square root 6. So again, I'm going to FOIL the square root of 6 times 4 root 3. So it's 4 root 18, right? Because the square root of 6 times the square root of 3 is the square root of 18. All right, square root of 6 times 3 square roots of 6. Square root of 6 times 3 square roots of 6 is 3 times the square root of 36, or 3 times 6, which we know is 18. All right, inside. Negative 2 root 3 times 4 root 3. Negative 2 root 3 times 4 root 3. I'm going to get negative 8 square root 9, or negative 8 times 3, which I know is negative 24. And then I've got negative 2 root 3 times 3 root 6. Negative 2 root 3 times 3 root 6. Negative 2 times negative 3 is negative 6, right? And then we've got the square root of 3 times the square root of 6, we know, is the square root of 18. So let's put that up there. Negative 6 root 18. What can I combine? I can combine my radical 18s, even though it can be simplified. Let's deal with that in a minute. So we have 4 root 18 minus 6 root 18, right? Which gives me negative 2 root 18. And then I've got 18 minus 24, which I know makes negative 6. All right. Square root of 18 can become what? Square root of 9 times the square root of 2. So I've got negative 2. The square root of 9 we know makes 3. So I have times 3 root 2, also known as negative 6 root 2. And of course, we've got the minus 6 going this whole time. Ta-da! And then, I don't know, some of you guys might see this. You could factor out a negative 6, and you would have what? The square root of 2 minus 1. This is really the answer I'm looking for, but you know, some of you see that next or that other step, but actually the answer, you don't want to have to be able to use the distributive property to be able to find the exact answer. All right, so that would be what we're looking for. Now, I've gone through this really fast. This video is in Google Classroom, so if you need to re-watch it and figure out what I'm doing, feel free to go and access it that way. But at this point, you are free to do your homework.